Hello and welcome back to a new video here on the Fusel channel, back in D3D12Ez. Now in the last video we managed to load a texture from disk. So we had the image loader and it loaded a texture from disk, and it's now ready to be used on the GPU, and that's what we want to do today. We want to upload it to the GPU, and hopefully we can also see it on the GPU because my Inside Graphics is playing a bit mad currently, but maybe we can do it. We're gonna see. Alright, so what do we need to do to bring this texture on the GPU? Now the first thing that we need to do is we need to have a resource description. Now we have done that for the vertex and upload buffer, and basically what we want to do now is, instead of just doing it with the vertex and upload buffer, I also want to do it now for my texture. So I'm going to copy that one, and we're going to reuse it in here. So this is the RD, and this is all going to be the RDT for the resource descriptor texture. Now, instead of dimension to buffer, we're going to put it to dimension texture 2D, because we have a two-dimensional textures. Now, the width needs to be taken from the texture data. So there we have the width. And then we also want to have the texture data.height. So width and height is going to go from here. The depth for array size is going to stay at 1. Mib level is also going to stay at 1. Now the first thing that we need to change is the format. So the format needs to go from unknown to the actual format of our texture, which is also in here as the GI format. Quality and count of sample, this is going to stay the same. The texture layout is going to change. It's going to change from row major to texture layout unknown, because we don't want to specify it. It should be specified by the GPU. And flags, I don't think that we need them. What flags do we have? We have allow... No, I don't think that we need a flag here. That's okay. So that can stay at none. Alright, so what we now have done is we have correctly described the texture, and now we just need to create a resource for that. So again, a comp pointer to I think we use bare resources here, yeah. Bare resources, and this is now going to be our texture in here. And now we can also copy that create committed resource, because this is actually exactly the same that we need. And I want to paste it in here. It's just only going to be the default heap, no heap flags. So do we need heap flags? Let's see. Heap flag allow. I think it's, well, we're just going to specify none. They're going to be automatically deduced on the type of resource. Resource state common is also okay just for now. And what I want to do is I want to provide it in here in the upload buffer. No, not between, as a replacement, please. There we go. So now we should have created ourselves a resource. Let's see. Let's break a breakpoint in here, press a 5 and see what we got. And we have, do we have a texture? Where is it? Texture. Yeah, the texture has a pointer associated to it, so it has been correctly created. Now the next thing that we need to make sure is we need to make sure that we get data up to the GPU. So you can see that we have our copy, which was basically calling initialize comment list or init comment list, and then we had like this copy buffer region, and then we executed the comment list. Now what we also want to do is we now want to copy the other data. So instead of copy buffer region, what we want to do is we want to copy texture region. So buffer region, texture region, that's the function that we need. But before we can do like the copy texture region function, what we actually need to do is we need to make sure that the data is actually on the buffer. You can see that we had the copy void pointer to the CPU resource. So basically we copied our vertices to the upload buffer, and that's what we need to do for the texture now as well. So let me actually grab that code block and put it in here. What we now need to alter is the size of our upload buffer, because the size of our upload buffer is currently only the size of our vertex buffer. So we're going to have an RDV for the vertex buffer, RDV. And what we then also want to have next to the RDV is we want to have an RDU for the upload buffer. And I know this is now getting really bad naming conventions, and it's okay, because this code is going to last like 1 or 2 more videos until we have like a texture quad on the screen. And as soon as we have a texture quad on the screen, we're gonna abandon that whole code, and I'm gonna rewrite that into a better framework that we can now then reuse for like real-time rendering. Now the upload buffer is going to be 1024 plus the size of our texture. So what we could do is we could maybe move our texture a bit up. Vertex data and texture data. And we're basically just going to create one big upload buffer for both, right? That's not an issue. That's possible. So texture data dot height times texture data dot width times, now a bit more complicated computation, texture data dot bpp plus 7 divided by 8, and I like to have brackets around them as well to be a bit more explicit. And now we should have the size of the texture also in the upload buffer. What I'm going to do is I'm actually going to do it the other way around. I'm going to first take the size of the texture and then the upload buffer, because textures might have alignment issues. It should not be the case, but I don't want to risk in running one of these, so I'm going to put the texture at the beginning and then the buffer. Buffers are a bit more handsome than textures. Texture. RDT, there we go. I even forgot to replace this here. So actually we didn't have actually a texture created, but okay. Okay. So yeah. So let's do CPI here for the texture as well. So actually let me defer that computation from here to, yeah, let's make it here inside D3D texture size. Let's defer the computation in here so that we can reuse it. We could also try to get the size of the vector, but I don't want to assert that it is exactly that size that we need. And of course I didn't want to put it in here. Where's my math? There's my math. That now doesn't work. There we go. Alright, so now what we have done is the destination was the upload buffer. This is no longer working now. So what I want to do is I want to make this a bit more explicit on what we are doing. Now, first of all, this is going to start at 0 and the other one is going to start at texture size. This is a void pointer now. Yeah, so let's make this a char pointer, which means that this one doesn't work anymore. So let's call this to a void pointer. And now this allows us a bit better addressing here. So the first copy for the texture starts at 0, and for the buffer it starts at texture size. Now the texture is going to be copied from texture data dot data dot data, and the size is going to be the texture size. Now this asserts that the whole texture is copied in the upload buffer, and then we copy all the vertices, and then we commit that. And this is now the buffer end is now actually gonna be texture size like that. 0. I don't know how end actually works, if end is actually included or excluded, but I think if we are putting end at the size, we should be 100% certain, but maybe we need the -1 back again, but yeah, we're gonna see. Alright, so the next thing that we need to do is we need to fill out this copy texture region, and this is gonna give you headaches, that function, because D3D and this function here it's going to give you headaches. You can see that we need to specify D3D12 texture copy location destination XYZ source box. There are many things that you need to specify to correctly copy textures. Now let's get started by the simple ones here. D3D12 texture locations is hard. So these ones are hard. But destination X, Y, and Z, it's kind of like the way specifying where the texture shall be copied to, but the destination is going to be all 0 because we want to start at kind of like the origin of the texture because we're going to copy everything. Now source is again complicated, so we're going to quickly leave it out. And then we have the D3D12 box for the p-source box. Now D3D12 box is a certain type. This is our texture sizes box. This is what this is. And what the box actually specifies is a 3-dimensional box that we can kind of like define kind of like a start XYZ and a end XYZ. And why is it 3-dimensional? Well, because D3D12 support 3-dimensional textures actually. Now left is going to be equal to top, which is going to be equal to front. which is going to be 0, which basically means we start at the origin. Then it's really simple. Right is again our texture data width. Then bottom is going to be our height. And then we just need to define back. And back is going to be 1, which basically means that it's just a one-dimensional texture, 0 to 1. It's like one range that we can copy. It's just important that it's not 0, because it would be 0. We would not copy any pixels. It's kind of like a volume that you need to see in front of your eyes. And then what we can specify is the box in here so that we have access to it. And now we are getting to the complicated part, to the D3D12 texture copy location. Alright, D3D12 texture copy location, txtc source, texture copy source, and txt's DST. So source and destination. This is DST. And this is source, and then everything is good. Now we need to specify them. So from where is our texture coming? Well, our texture is coming from a resource, which is our upload buffer. Now, what kind of resource is the upload buffer? So what is our type? Our type is actually a so-called placed footprint, because now we have actually placed our texture in a buffer. So it is placed somewhere with a certain footprint. Now, if we do need this footprint, we need to specify how this footprint is laid out. Now, the first thing is an offset. Our texture is at the beginning of the buffer, so the offset is 0. Then, what we need to specify is the actual footprint itself. The footprint itself has depth, format, height, row pitch, width. It's quite simple, right? We specify a width, which is our texture data width. With, not wig pixel format. And we also have a height, which is also very trivial, our height. And we also have a depth, because it's 3-dimensional, but since we are not using depth, this is going to be at 1. And now we are getting to the bit more involved footprint features. We have a format and a row pitch. Row pitch is quite simple. This is our stride. And again, let's maybe go back to our calculations up here. And let's defer them to up here. So I computed the texture size. So let's start with the texture stride. The texture stride is going to be the width times that. Like that, double brackets. No, what? Like that. Yeah, it was okay. Texture stride. It's gonna go in here, and then we have the height, and then we have this a bit deferred, so that I can specify my texture stride. And here is the row pitch, because it's like the pitch between rows. And then what we have is a format, and the format is the DXGI format, which comes from the texture data GI pixel format, and then we have correctly described our placed footprint. Now the placed footprint, again, it's basically just telling DirectX how the texture is placed into memory. So width, height, depth, row pitch, format, and with that information, DirectX can interpret how the texture is laid out into normal memory. With the offset, it knows where to start, and with the resource, it knows which memory pointer to kind of like offset with. And now you basically have described where the texture is laid out. Now we just need to describe where the texture should be placed. Now the texture should be placed on our texture resource. Texture, there we go. And now this is no longer a placed footprint. Now this is a so-called sub-resource index, because it's now actually a proper texture resource. And the sub-resource index, you can see, doesn't have any members. It's just an integer. And since we are not using sub-resources, we put it as 0. And this is then now correctly describing where we want to copy to. And if we didn't have made any mistakes, this should work. Let's see. Maybe I should have made a... Okay, it didn't work, so something has gone wrong. The question is, what has gone wrong? Interesting. Nothing has gone wrong, but we no longer see triangles. No longer seeing triangles means we messed something up. Do we still have our buffer region? Yeah. Alright, so the problem is that we are currently copying our buffer without an offset, right? You can see that we have the destination buffer, destination offset, source buffer, and source offset, and the source offset is now set to 0, so we actually copied our our triangle from the texture data. So texture size needs to be of course specified in here so that we have an offset of our vertex buffer. And if we put that in here, yeah, we get our nice big ass triangle again. Alright, so now let's go out of here and let's take a look on the code and let's actually try out and see if my Inside Graphics works today. It's always a madness with these graphic debuggers. Sometimes they just break. I don't know. Let's see. It never braked on the D3D12Ez. So let's see, maybe this one is still working. Maybe it was just a certain thing that I used on my old one. And of course, we need to compile this in release. If we're not compiling it in release, it's not good. Let's build that. Why is that now failing? A problem with the pixel shader? What's the problem with the pixel shader? Why is it breaking now? Ah, because we just switched the shader model for debug. Shader model 6. Yeah, we just have configured the shader model for one thing. So let's use shader model 6 for all configurations. Just probably gonna fail for another one. Root signature, now it's at the vertex shader. Yeah, basically we forgot to correctly configure them. Shader model 6. What is with my root signature? Generate root signature, that's okay. Alright, so now this should be good, right? This should now be also built in release. I hope I set it up the path, so let's quickly validate that. Okay, that's working. Let's now go in Inside Graphics and try again. Now the working directory now needs to be explicitly set to our app directory so that it can load the texture. Interesting, we can't launch because Inside Graphics is a bit. Okay. Now it's giving us the options. Let's see. If we get what we want, let's keep it. And let's see. Alright, so let's hit F11 and see if my Inside Graphics crashes. No, it actually works. And it is the third project that I have used. Alright, so now we are inside of our Inside Graphics frame debugger. And by the way, actually what you can do now is you can actually see how our triangle is drawn. I think we haven't seen that yet. You can see it's completely black. Then you can see it has been cleared to the color the buffer. Then you can see that we rendered the triangle. You can see it's actually highlighting the triangle and actually move around the frame if I want to. And scroll in and see how it works, but you can see like that the triangle is highlighted, and this is then like the present event when the final frame was presented. But that was not what I intended to show you. I intended to show you all of my resources and show you that our texture is on the GPU. So if I go in here, you can see that this is my all resources tab, which is by frame debugger all resources. You can see that we have these textures here. These are, if I open up the flex, allow render target. These are my two render targets. One of them is currently render target. So you can see that we have revisions in here and we actually have our triangle in here. One of them is not render target, so we can see it. No current swap chain buffer. We have two buffers down here. One is our upload buffer. This is that one. This is our upload buffer. And the other one is our vertex buffer. It's that one. And now you can also see that we have a texture 2D up here, and this is our image texture. Now, texture 2D, if I would open this up, you can actually see the texture here on the screen. You can see that this texture looks a bit ugly, with like all these dilations going to the left. But this shouldn't be an issue because the alpha channel is 0. Alpha channel is 1 in here, and somewhere we have a cutoff to 0, and so the pixel would never show. And it's currently showing it a bit like that, but I think there was a way to actually change that. You can go in here and actually change the shader on how they are displaying the textures, and it's actually quite a madness that's going on here. You can actually change how they are doing it, how they are rendering the texture here inside of Inside Graphics. Alright, but you can see that everything else is working. We have the texture on the GPU, and now we just need to use it, and that's for the next video, because it's actually not that simple. And maybe we need 2 more videos, I don't know. But at least like 1 video, we can't do it yet. So, yeah, let's click on terminate here to terminate the process and make everything crash. No, it didn't work. So yeah, thank you for watching. See you in the next video where we're gonna put in the texture into, or try to put in the texture into use. Thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.